get started. It's about time. This talk is testing and production the right way. I'll start by talking a little bit about me. I've been a programmer for 20 years. I see some of the speakers at this conference, and their names I know, but I'm not probably anybody knows. However, I have spoken at KCDC for a long time, back when it was a new conference and it was like 100 people or something at Johnson County Community College. So I want to point out though that the only thing that really sets me out to speak is that I care about this subject, and I put it out there and they'll take it. So KCDC is actually a really good place if you just have even the thought that you could be a speaker. I would definitely jump in. So I am a big guy into TDD. It changed my career. I've been using TDD for, 10 plus years, and I can't imagine life without it. And I'm sort of also the Uncle Bob clean code kind of disciple. And I put a note here, I feel like a pathetic developer when my software doesn't work. There was a time in my career when I thought about quitting programming because I could not make anything that didn't have some bug or didn't cause some big problems. So I definitely don't feel that way now. Now I can't imagine doing anything else with my life. So I'll start with a story of failure. Now I wasn't involved in this project. I came on to the company when this thing was wrapping up, so I wrote the post-mortem on it, but so I'll just get into it. And I'm going to summarize it. This story is completely true. I'm keeping all the names out. So I'm just going to say there was a business, a blue-collar business, had lots of customers throughout the whole Midwest, a well-known business. They had this idea that they wanted to engage with their customers. So the plan was to make this little project where they hired an ad agency they worked with that also employed me, and that's when I came on. But they had this idea that they would send emails and postcards to their customers, and the customer would receive the postcard, and they would go to a website and they would answer some questions. And if they answered the questions and clicked submit, they would be given a thank you, and they would be offered a hat. And the hat was a hat, I'll summarize it, but it's something I think that somebody would want. So there was a little bit of an incentive to answer a few questions, but it was also a place for the business to sort of re-engage with the customer, remind them they're around, and maybe start some conversations. So the customer gets the hat, but then the company gets the data, and we're just going to call that an engagement. The application was like any other application you'd expect. An email or postcard has a unique link in it. The unique link will take the customer to a survey, no login, we know who they are because they have their own special link. Then they get to pick a hat, then they get a thank you. And all of this stuff is driven, it's through a central database. And it's all simple. It's a Ruby on Rails app, and the only output really was this admin CSV report. So the project manager of the company could just download this report, and they'd have all of their data back. And I'll point out that it was tested. The Ruby on Rails people, they in general like to at least put some testing in their application. There was acceptance testing. Everybody went through it, so they considered this project to be tested as well as any app like this should be. So that testing included acceptance, where they start with an empty database, but they load it with a few records in all the appropriate tables, and then the customer, the programmers, they all go through it. They tested this thing out pretty thoroughly. So it's launch day. So what do they do right the day before launch? They load it with all the real data. Now, the real data is a lot more than 100. Like I said, this is a very large customer, and I'm just approximating it at about 150,000 records. So this database went from being a tiny database to being a big database. You come on in, don't worry about anything. So this application that was fully tested and everybody felt good about, it already had its first problem because there was so much data that this one export would not work. So the admin could log into the system, but the report could not be downloaded because it's just too much data to pump through. They tried increasing timeouts, some simple fixes, but this just was a no-go. So this application was out and running, the postcards were mailed out, the emails were sent, but nobody could see what was happening. So the project manager responsible for this, tells the programmer, hey, I'd like to see what's going on. Can you look at it? So the thing is, this project was considered done, so the programmer had moved on. Programmer's paid by the hour. And the programmer's kind of annoyed. It's a big pain to have to run reports for this application, but the programmer does it after, it takes a programmer a few days because the programmer has to download the whole database and then run it on his computer, and so he's a little slow with it. Takes about till the end of the week. So programmer runs the report, sees nothing but errors. Nothing worked. It's like the application had been dead. So the problem is that they had all this pristine data when they were testing it out, but when they loaded the customer data, they didn't really get what they thought they would get. Now the customer thinks their data is good, and it was good. The programmer had assumptions built into the kind of data that they would need. So I would actually kind of say it's more the developer's fault than the programmer's fault, because I could tell you it was a null error on some stupid page, right after you finish your survey. So everybody who responded to the link to the postcard, they started the survey, they filled it out, and they just got a big error page, and nobody could see it. So this application, again, like we say, is fully tested and good. Actually, it had errors. It had problems. So the programmer does what programmers do, finds the error. It's a null error. Puts, the fix in on it, pops a GitHub pull request. He merges it. He then logs into EngineYard. EngineYard, I haven't looked at it in years, but it used to be like a wrapper around Amazon. So you could have your app, and then you press deploy, and it would just deploy the latest version of your app. So the programmer presses deploy, the application gets launched, and he says it's fixed. So we think we're back up and running. Okay, the errors are fixed. But again, the project manager's like, I still can't see what's going on. And the programmer's like, God, this is like, the programmer's not getting paid at this point because the project also went past budget. But programmer, a few days later, finally downloads the database, runs the report. Nothing but errors still. So we're back to this, where the application is not functioning. Now the programmer knows, I fixed it, I saw it, I actually tested it and it went fine. Problem is, and this is just a eccentric part of EngineYard many years ago, and maybe it's just the way they set it up, but it wasn't enough to press deploy, because if you made the change he made, which was just in a view, for whatever reason, you had to press the restart button too, because it would deploy the app, but the view changes would get cached or something, I don't know, whatever, but it wouldn't actually work. So he logged in, he goes, oh yeah, I remember now, it presses restart, and it's fixed. So we're back up and running. Probably a week later, they run the report, and they had successes. But at this point, it had been about 2.5 weeks, I think, approximately, and they missed their window. They mailed all these postcards out, they sent all these emails, they had hundreds of responses, maybe thousands, but they all came in that first window, when the application wasn't functioning. And they had like 17, it was a ridiculous number. So this application was, a complete failure. Problem is, though, money had already been spent. I don't think a lot of us kind of get into the money, at least the development side, but the idea was the business pays the ad agency hires the dev shop, and the dev shop pays the programmer. So the money comes from the business, money is dispersed as the work is done. And the goal is the business pays the money, but they get the data. What happened in this case was only the programmer got paid, because it's weird, but in this field, programmers can miss whatever we want up, we still get paid. We never pay out of our pocket for these mistakes. So programmers paid, the ad agency ends up having to pay, the dev shop eats it, and the business just eats the rest, because, they got calls and stuff. They're like, well, why is, They just look foolish. And plus, this ad agency had a constant relationship with this business, so they looked like they had egg on their face. So they say they're sorry. Dev Shop, no joke, I can't tell you who it is, I can't show you the blog post, it's still out there, but they actually wrote a protesting blog post as if they cared a lot about testing and they were experts at it. And the developer went off to do whatever. Again, I can't name names, but this was a complete failure. So if we look at the problems that happened in this tested application, broken report, the little trick with the restart, the time it took to get responses, and the actual bug. These all combined to make a fully tested application be nothing but a failure. So this kind of stuff is why I decided I wanted to give a talk on testing in production, because I think this is the solution to these sorts of problems. So I'm going to start by introducing a hero, because this is the solution, I think, to these sorts of problems, and I'm just going to call it the count. I'm calling it the count because there are lots of words that I could use and people will use that I think are more appropriate, but like if I say event, it's just I don't want you to tie this to all the other talks you'll hear about event architectures and all this stuff. We're just going to have this, we're going to call it the count for now. We're going to think of something like this, right? We have a visual representation now of the count. He's going to be our hero. So I'm going to break this application down a little bit. Now, I don't know how many developers, everyone here is a developer or acquainted. We all know how these applications work. You have an email, and it has a unique link in it. Well, the unique link is stored in a database table, right? We all know that. Here's the shift in how the count is going to help us. When a record gets added to this table, whenever we create a unique link, we're going to make another table. I'm just going to call it the count for now. And I'm going to make a record of it, saying I created a unique link. Now, I don't have so much space on a board and my handwriting's poor, so there's other stuff you can put in here. I'm just summarizing. This is not your full schema. So continuing down the application, when somebody clicks the link and they go to the survey page, we're going to write a link or a record in the count saying a link ID was used. When somebody uses a link, and let's just say the link, so I don't want to jump ahead a bit. Oh, this is where the link was used. Side note, I added a who column. Yeah, that's right. So that who column, since we know a little bit more information about them, I'm going to add who did it. And because I know the unique ID is tied to a customer and the customer is the major thing, I'm going to put the customer ID in that who column. Well, let's say that they use a bad ID. And this is where kind of testing and TDD sort of comes in. You say, well, what if the link doesn't match a customer record? Or the link is bad? Well, we're going to store that as well. So if a bad link is used, we're going to make a record, but since we don't have a customer, I'm just going to stick in the URL segment as the who. Let's say that somebody uses a survey link again, which is something we probably test for, for using traditional unit testing. I'm going to throw it in there as well. Continuing on, and I'm not going to get into every detail, but like let's say that somebody submits a survey. I'm going to record first that they were presented with the survey. I'll record when they submit one. I'll record if it was invalid. I'll record if it was valid. I'll record if the survey was saved. Then we get to the thank you. They made their submission. I'm going to mark that. I'm going to say if they selected a bad hat, like I don't know how they could mess that up, but if they did somehow, I'm going to say if the selection was good. I'm going to mark the selection was saved, and I'm going to say they were presented with the thank you page. So the counts table is essentially going to provide an audit of what happens when it happens in production. And this is an important thing I'm going to say over and over again, but this is going to be independent of our architecture. And I'm not checking my phone for anything other than the time. It's independent of our architecture. We can build the application without this, and then we can put this in at the end. And it's stored in the same database. So this starts the first part of what I would consider to be appropriate testing in production. You need to count everything that happens in your system. You could say, I want to log it. There's lots of words here, so I'm trying to avoid logging events, all this stuff, but you just want to count. It needs to be independent of the system, Because I don't know how many here, I build event-driven systems, right? Anybody here do that kind of stuff, you know? It's very important, I build it, right? But your application doesn't have to be that. And I'd even say don't tie this, if you have an event-driven system, don't tie it to your event-driven system. We want to use business terminology, so we're not going to use programmer words, things that nobody understands. We're going to use words that the business can follow. And since we're recording when something happens, everything needs to be in the past tense. A link was used, you know, that sort of thing. Used, past tense. So, isn't this just logging? I mean, you might be thinking that. And in a way it is, but what I like to do is to get into the testing side of it. You know, we've kind of built data, now we're going to test. So, how many here do unit testing or do anything familiar? Generally, people are familiar with unit testing. So, general principle is, at least a good rule of thumb is, you usually have an arrange, an act, and assert. A test is broken into 3 sections where the first one is you arrange the test, the things that are going to be acted on. Then you have one act, so something happens, right? That's what you're testing. And then you assert your expectations on the results. Now, our applications, like here's the basic parts of the application. We know that this application is composed of lots of little classes. And people like me who use TDD for everything, we're like, oh, I'm going to build all these little classes and I'm going to make sure each one is independently functioning. So anybody here mock objects, you know? You take a class and you completely isolate it from all of the dependencies and you do all this stuff. So you have all of these little modules that are tested independently. And then everything works perfect, right? No. You know, and this is kind of an embarrassing part. Like, oh, if I write TDD, I'm going to test everything, it's going to work great. Errors are still going to occur. So then some people will say, well, to fix those errors, what we're going to do is we're going to start grouping the classes together and write more, let's just say, integration tests. So instead of just testing each class isolated, we're going to keep them in groups and we're going to test those. But you do that, I promise you, the errors are still going to come. Then some people will say, well, let's test the whole application through the browser, and then we'll know for sure it works. And we're going to bring in the business, and we're going to have other people do this. This is going to be acceptance testing. Everybody's involved. And you can do this, it's still going to have errors. There's no getting around it. So when we take software testing seriously, we usually use TDD, and I'm summarizing, and I know there's all sorts of words that can be used here, so I just kind of break it down to TDD or BDD, behavior-driven development, you know, more of the integration type of test, where we declare with our test what we want our code to do. It's meant to be our hopes, you know, kind of like this is what we think it should be. Our tests are written in the future tense because we're saying when this happens, the result should be this. We run it in a different environment, the environment being our computer, my laptop right here, and we center it around test cases that we know or that we think are going to happen. So like in that situation when I drew up all those scenarios of like, what if it's a bad link? What if they use it again? These are all things that came from my mind thinking, how could this system be used? So getting into testing and production, I'm going to just take this one section where they fill out their survey. I'm just going to take one part of it. So we know all of these things could really happen. Let's just focus on these 2 to start. So if I were to write a unit test, I would say that whenever a valid survey is submitted, the survey should be saved in the database. So this is what a unit test might look like. I'll declare here's a valid survey. On my controller, I'll pass that survey to the controller, and then I will verify that somebody called save on it. You know, that's unit testing. That's isolated from the database. It's clean. Tests run super fast. People say, well, I want the more integrated test. So those are essentially the same, except they'll actually check the database. I have really bad handwriting. You just have to speaking it. You know, it's driving me more than this actual good for reading. So it's basically the same, but you're going to check the database. Now you get this extra layer of protection. I know it's saved to the database, so you know we're covered on that. Then we might get into acceptance testing. Does anybody do gherkin, cucumber, that kind of thing. I don't know if that's what people do these days. Things. They use SpecFlow. Use SpecFlow. I'm the second leading contributor on SpecFlow. I wrote the code that does the table integrations. So I've used SpecFlow for thousands of tests. But they kind of come out like this. But again, it's still that arrange active serve, where you're going to say, given the customer clicks the valid survey link and they fill it out, what it will do in some cases, it'll actually open a browser and it will actually enter the information in. And then the act is when the customer clicks submit, it'll click submit on the browser, and then it will verify that all this stuff happened. So no matter how we build these tests, we set up the code, and then we run our test cases against it, and we get these nice green checks. We're thinking, okay, this is great. I know this application works. And then we say it works on my machine because my tests pass. So then we think, oh, well, we take testing really seriously. So we're going to push our test to everyone else. And then those tests are going to run against everybody else's. So all the development team, they're running your tests and they run on their computer. And then we say, well, now they work on all the machines because we put, deployment machines, test machines, build servers, all these things, and they all run our tests. So we have this protection, like all these computers are running the same test and everything's green and good. But we skip this step, and this might as well be a brick wall, force field, something, right? Who runs their tests in production? There's scenarios where, situations where that would happen, but in general, we don't. In general, we say we've tested it in all these different areas, so it should work, and we just take this application, we deploy it on another server, and say, we ask the business people, why don't you look it over and check? We might check it, but that's about as far as our testing goes. So if I were to write a test in production for this happening, and I'm counting all this stuff, I can take those two scenarios, the same test I'm running, but make it past tense. So I'm going to pick a date range, and I'm just going to say this is an arrangement right now, and then I'm going to count the records that happened in the database. So for every survey that was valid, I'm going to also check that I have a matching survey record. And hypothetically, if there are 240 valid submissions, I should have 240 surveys saved. I think you'll find if you do this, it's really simple. We're just counting things. But you're going to find that when you set these applications out into production, you're going to have, it's like the customers will give you thousands of unit tests, thousands of test cases, I should say. And they're all going to just be good, and they're all going to work like you think, except when they don't. Because you're going to find, hopefully you don't, but I promise over time you're going to find that sometimes unwanted or unexpected things are going to happen. So that's why, going back to the whole idea of testing and productions, after we've counted everything, what we want to do is take the same sorts of assertions we make in our unit tests, and we want to verify that they happened in production. The count data will verify what our tests say should happen, and when it doesn't work, failed assumptions, that's new cases to handle. This hit me yesterday. I do a lot of e-commerce, and I noticed an application. I have a test that says errors shouldn't happen, for this in this one scenario. 2 popped up yesterday, and it turns out that our payment processor, if you pass it a credit card number that's less than 12 characters, it throws an error. It doesn't return a validation error, it throws an error. And we trapped the error, everything was fine, but it's something I never thought of. I just never thought, okay, let me put a check against that. So, I'm just telling you, this happens every day, and I do this, and it works out. So, surveys valid, surveys saved. So I kind of wrote this up as a test, right? We should check counts. How would we do that, though? There are lots of ways of doing it. I'm just going to tell you how I do it. This is not the only way. It's more important that you just do it in some way, but there's some really easy ways to handle it. The test runner, we kind of need a test runner to run this. So the test runner is going to be, first of all, our eyeballs. Humans looking at data. There's no getting around it, and we'll get into this. And I will say there will be some automated tests in this, but in general, I want to start with a human investigating the data. So remember that report that failed? What if we just change that report, instead of dumping the entire database, what if we change it just to report counts for the last 24 hours? This is how many events happened. So if we did that, these events would be in the CSV report. The CSV report would work because SQL databases are very good at grouping and counting. So we could dump not just 150,000, we could dump 150 million. That report will not fail. And the customer would be able to immediately see there was a problem. Survey was valid, survey not saved. They would see a 0, they would have immediately known. What I use is an application called Freeboard. Anybody hear Freeboard? Anybody use dashboards, like build data dashboards? Yeah. So I use Freeboard. It's a free one. You can get on GitHub. They have a hosted service, which is great, but they also put it out on GitHub. So I like to have it running on my computers. So this is the kind of idea though. You have all your data being displayed on a dashboard. So this looks all fancy, and you're going to look at this and think, oh, I've got to program all this, and what? You don't. Because let's just focus on one part of their picture. You can't see it very well. They have in their picture, they have a widget that just shows a sentence and a number, a sentence and a number, a sentence and a number, which could look just like what we need for our systems. So I could use a Freeboard. I do use Freeboard to very easily just return counts. I just want to put counts on a TV screen, computer screen, whatever. And so I could just have an API, I use an API for this, where I'll pass it a key like the survey was valid, and I'll give it a time frame, like minutes ago would be 24 hours. And it's going to return an API, a small little block of JSON. And it's just count, colon, and the count. Really simple, right? I mean, this is very simple. And then I can just have that number reported with Freeboard on the board. So this data can immediately be pushed to a screen. And then with Freeboard, you can say update it every 5 minutes, every hour, whatever. It's just going to make another AJAX call and put the data in there. Now, I make boards that are 4 screens high. And I even programmed it so it's like it'll start at the top of the screen, it'll wait like 5-10 seconds, and it'll move down just a little bit and stop, move down a little bit, stop, go down to the bottom, and then it'll move back up, So this TV, and I put it on a television on my desk. So I'm always just running this board. It's just full of data. And there's no way for me to even follow. Like if I have a screen full of all these numbers, they have no meaning. I'll not be able to see the counts. I won't be able to notice that, like in this case, what if one didn't get saved? So this is where in Freeboard, they call it an indicator light. I always call it the check engine light. You never see your check engine light. It's on your dashboard in your car until it comes on. And you're like, oh, that's where it is, because it just suddenly appears out of nowhere. I would recommend that you consider this for those test scenarios. So we wrote the unit test, we know that this count should equal this count. So using Freeboard or whatever tool you want, I would recommend just having a light that only appears, like you won't even notice it, so long as these numbers match. But if they don't match, a little light comes on. Now, not dealing with the house, but basically I've been working at home since COVID, and I have this TV running, and the room is next to the kitchen and everything. And I have this TV running, and the TV's on all day, and it's just pushing numbers. Even when I'm at home, it's the weekend or whatever. I can just watch the TV from 20, 30 feet away, and the board will move, and I can just see, are any lights on? No lights on, everything's fine. There's another way of displaying data, and I'm trying to show you what you can do with just a simple count. So when we show this count on the screen, like in this case 240, well, you can add a spark line. And I don't know if there's lots of probably words for it, but it's not a thing where you show data in the past. What it will do is the next time you make that AJAX call, it'll just move it'll make a little graph that it'll basically create a line graph for you. So without you doing any extra programming, just over time, if the number goes to 250, you're going to see it go up. If it drops to 230, you see it go down. So if you have this TV screen running and it's displaying data and refreshing data all the time without any additional programming, with the same single API call returning one count, you can get a time projection. Or not projection really, showing it in the past, but you get to see how things are. So you can just look at it and see, are things stable? You know, because there's lots of things, lots of ways of looking at this. If you see this, what can you expect? Let's just say this was showing orders. We're getting more orders, right? It's showing logins. More people are logging in. They're using our system, whatever. What about this? It doesn't take any training, doesn't take special programming. Anybody can look at this graph. If we see it say logins, we're going to see people are not using our system. Like they started high, and now ever since then it's been going low. We can see this means something's stable. Sometimes we'll see erratic behavior, good or bad. Right? How does this make you feel? This should scare you, right? It scares me if I see it. But this is what we often miss. And it's when things are functioning great, a problem happens, things suddenly go down to zero. Your order system fails, people can't make orders. How many orders do you get after that? 0. We can see that. It doesn't even take the developer writing a test for this and making some complicated thing. If you can just put this in front of somebody who cares, a stakeholder, and have it on their screen, and they can glance at it, once or twice a day, they're going to see that, and they're going to raise the alarm. What about this shape? Does this shape scare you? Scares me, because if I see something that I'm not expecting to happen, and it's not happening, and suddenly it spikes, this is like, if I see this like in an error log or something went wrong. Something different. I don't like things that are different. I like things to line up. So if we take this API call, I'll tell you, this is another way I handle this. So there are certain things that are fires. Like if I get 0 logins on any of my systems, nobody logs in 4 hours. I'm just going to make up a number. It's a fire. If we don't get an order in a day, fire. Something is wrong. And this rule applies today. The e-commerce system, one of the ones I'm running or maintaining, it's been around for 10 years plus. The rule has always been the same. If you don't get any orders in a day, something is wrong. Maybe it could be 6 hours, I don't know, but something is wrong. So in this API that I made, I also throw in variables like throw if greater than 0, or throw if greater than, and I can give it a number, or I say throw if less than this. So what I make this do is, this API is, if I give it one of these green variables and the count doesn't meet the rule, the page throws a 500. Then, anybody use something like Pingdom? Anybody hear of Pingdom? Right? It's a service where, and there's lots of competitors. I just use Pingdom forever. All they do is they ping your site, right? You pay them a certain amount of money, and they'll just ping your site every minute, every 5 minutes, whatever. And it's meant to be that you can make sure your site is up, because if your site's down, they ping your site. They ping it from servers all around the world and everything. It's really neat. So when your site goes down or it starts throwing errors, it alerts you. Your phone rings, or you get a text message, the alert pops up, all that stuff. So I take Pingdom and I point it at a special, that API, but I give it a special throwing variable. I give it essentially a test. And that test is run in production every minute, every 5 minutes, whatever. And when it fails, I know about it. I use this for things like server counts. Sometimes, I run a bunch of back-end, instance servers that run different things, and whenever we run a deployment, or let's say one of them goes down or something, if the count goes from 7 to 6, I get my phone ringing, and so when we press deploy, I kind of test my test as well, because I'll know that it'll go off when it's in the middle of deploying everything. So I want to link this back to TDD and BDD, because the principles are the same here. It's just we apply them differently. So in TDD, we declare what we want it to do. Production testing, we're going to state what happened, regardless of our intentions. It's just stating facts. TDD, we give our hopes. Production, we get the truth, what actually happened. TDD and BDD is future tense. Production is past tense. We're testing, what happened. This is the big one. Everything, when we run our tests, they're usually run in a different environment. These tests are run in the real environment. How many people have had systems, you deploy them, everything works great, the configuration was off. Somebody typed an extra N or something into it or something. Yeah, I mean, it's happened. Your tests don't matter. They don't cover that kind of thing. This will. And this is also an important one. Instead of just centering around test cases we know, we can now write tests for things we never imagined could happen. And I don't know about you, but I can't think of everything. Seeing how thousands of customers use your system will teach you something. So linking this back to the overall look on testing and production, we want to make the count available for everybody to see. Put the counts in some sort of easily digestible form, dashboard, report, something people can get to easily. And then I would say you can use these same counts to then monitor for dangerous situations. So you might be thinking, did I just attend a talk about counting? And you did, right? It seems really simple, like, you can almost, I could say this in 5 minutes. Just count everything that happens in your system. And I'll even say counting is not the only way to test in production. But I think it's the easiest. And it's something so easy, we overlook it. Because it's weird, like I say, like non-technical people know how to count. Technical people might know how to count. We build systems that are so complicated and have so many details. We often miss the simple things. A simple, and like we'll even take principles like I want to build a CQRS event sourcing application. This is how everything should work. It almost seems like sacrilege to start dropping in some counting here and there. Like, oh no, we're going to make it complicated. We're going to hook it to our event store. We're going to do all this stuff. And if you could just put a little bit of counting here and there, you will solve problems. And it takes no work to do counting. It takes no work to drop one line of code in sensitive areas in your code base. It's safe. And to me, I would think of it like it's a great bang for your buck. A few little lines of code here, an API maybe on the side, one API to cover all of your counting. That's a lot of value. We tie this to the problem that my original situation had. Broken CSV report. A simple count would have fixed it. They could have reported the counts. The restart, that would have caught it because they would have seen the thing still sitting at 0. And they still would have seen the other count up high. The time it took to get the data, to find the problem, all of that, this would have helped solve it. It would have shortened that time considerably. And when it wouldn't have fixed the bug, but we would have seen it from day one. We would have seen it from hour 1. So if we could imagine you're the business and not the developer, right? If you could take this business and this ad agency through a dev shop, through a programmer, gives you this application and they say, this thing is tested, we've done our job. Which one do you want? Would you rather have this application with all of the time spent to testing? Testing takes a little bit of time. Or would you rather than just count the data and put it on a dashboard? What would have worked better for the business? For the business, they're going to say every time, I want that. Programmers, and I'm a programmer, I do this every day. We think of this as being our responsibility. We even sometimes tie morality, like this is what I should do. We need to think more about the business because they pay us. They're buying something. Who here has a car? Who ever owned a car? Think of a car manufacturer who just builds a car and then sends it off and they're like, whatever, No, they need to know what happened. Did the car break down? Toyota, did the brakes stop working? They need that information so they can make everything better. So now I'm going to say things that I'm almost purposely going to troll you here, but let's take something like something that I don't think is debated much, but this is the testing pyramid. right? The idea is that your system should have a base of unit tests. So you have a lot of unit tests covering a lot of those classes, but then you write service tests, UI tests, whatever, right? But that you have fewer of those, but they cover more. So I pulled this from Martin Fowler's website. You know, you get more isolation at the base, but you get more integration up top. But then the tests run faster when you're isolating tiny little things, but then when you start dealing with the database and other things like that, things get slower. Let's start thinking about it like a business. Down here, the tests are cheap. Up there, they're expensive. Down here, the tests are easy. It's really easy to write a 3-line test, but you write a test that's running through the browser and doing all these fancy things and then checking and then delaying, make sure everything happens. You know, I've written a lot of these tests, right? I've done more spec flow, I bet, than anybody here at this conference. They're hard, and they're hard for other programmers. You know, I teach programmers too. I mentor programmers. I'll just tell you, it's hard enough to get a programmer to understand unit testing and really be confident and good at it. I don't even touch spec flow with a lot of people because it's a lot to ask. And then, this is more of the sacrilege part, but down here, you get a lot of bang for your buck. I use TDD because, not just because it covers my tests and makes sure my code works, but it helps me design my code. You know, it's neat that like you think, oh, this is what I'm going to end up programming today, and then you jump in your code, and then you start writing your first test, and you end up building something completely different. You know, I've been doing TDD for 10 plus years, so I'm used to that, but you're still going to get a lot of bang. So I get a lot of bang from these little tests that I write. But when you get up into these more integrated tests that hit into browsers and all that stuff, I'm going to say it's waste, because I've done this a few times where how many people have written browser tests? You know, right? They are really expensive to maintain over time. Somebody might want to change the UI. They might, you can take one little change and it could blow up a lot of tests. And they take a lot of time and expense to keep functional, not just to write, but to keep maintaining over time. A unit test, no big deal. You know, the code doesn't touch; it's going to keep passing. But over time, browser tests fail. I give you an example. I used to use Refinery for small little one-off content sites. Refinery CMS for Rails. So you pull the project down, you run the tests, they work great. They're integration tests. You know, they hit the site, right? As soon as you take that's probably fixed, or I don't know. This is years ago, right? But as soon as you took the Refinery header out of the admin system and you put the customer's name up there, integration test broke. You know, it's like from out of the box, you're maintaining these tests. And I call them waste because honestly, they get thrown away. I've seen in a lot of cases, people drop them. So they spent a lot of time building them. Eventually they had to, it's almost like a sunk cost here, So I'll tell you my priorities. My priorities are to focus on unit tests. So I'm gonna say 1A, 1B. But anything I build, I will use TDD as much as I can. And I will count. I will put the counting in as a top priority. I must be able to verify that this code works in production, and I need to be able to demonstrate it to my clients. Then, with the extra time that I have, I'm probably going to go back and polish this a bit more. We have limited time, so we kind of have to decide how are we going to use it. So, I make a little fancier things on my free boards. My APIs have sort of grown over time. I can do some fancy things with them, but I'll sort of polish them. Then the next one is I'd rather take a nap at this point. I'm resting. It's enough almost in a way at this point. You can take a break. You can't just put everything in. Then, I'll be honest, I don't use spec flow. It's too hard to maintain right now. And I have a really good development team, and it's still a lot. And it's not going to give us the coverage the counts do. So if I want to go into these tests, I'm going to actually do it by using counts. And the neat thing about the counting and the API stuff is that you can hook tests in a way up to your dev and your test systems. You can How many, I mean, we kind of all have to. We're not writing simple apps. I feel like a lot of people are writing complicated apps that have background processes. You know, somebody clicks a button, they kick off a job, it kicks off thousands of other jobs, and it might take a little bit of time, but over time, eventually things will reconcile. I mean, that would be the event sourcing side. Things will reconcile, your views will get rebuilt, and everything will work. But there's time and stuff involved, and I'd almost rather, when we have all these background systems and the UI systems and all this, I'd rather just let them operate as if they operate and then look at the results later. So this will kind of get back to the original story. If they had employed this type of testing, this would have turned this story of failure into trust, but verify. You know, trust has to be earned. You can't. It's not something you can just give, or you just shouldn't ask for it. You know, it's let me show you the system functioning. Let me show it to you, and then if they see you taking these efforts just to make sure this thing works, they're going to know you care. When a business sees a programmer and they don't want to run the report, like they're not fixing the problem, they won't trust you, and they won't like you. You put a dashboard that everybody can see, everyone's on the same board or on the same page, literally almost, and everything will be good. So that's the end of my talk. Again, that's my name, email address if you have any questions or want to talk. Yeah, so we have this 46 minutes. Does anybody have any questions? Any thoughts? Yeah.